Hi viewers, I'm Shankar, and in this video we are going to discuss about ambiguity in grammars and languages from compiler design, as well as it is common for TOC also theory of computation also it is the same. And let's go to the video. Let us see first what is ambiguous. A grammar is said to be ambiguous if there exists more than one leftmost derivation, or more than one rightmost derivation, or more than one parse tree for the given input string. For example, if any grammar is given, context-free grammar is given, if you want to prove if the grammar is ambiguous, then for the same grammar, they have given one input string. If you are deriving the input string with more than one leftmost derivation or more than one rightmost derivation, or if you are constructing more than one parse tree for the given input string with the given context-free grammar, we can say that the given grammar is said to be ambiguous. Then, if the grammar is not ambiguous, then it is called as unambiguous. If the grammar has ambiguity, then it is not good for compiler construction. And also, there is no method can automatically detect and remove the ambiguity. But we can remove ambiguity by rewriting the whole grammar without ambiguity. And let us see one example for checking whether the given grammar is ambiguity or not. The given input grammar is E derives I, and E derives E plus I, and E derives E star I, and E derives bracket E, and I derives epsilon or 0 or 1 or 2 up to or 9. And input string is 3 star 2 plus 5. So for using this grammar, you have to derive the string that 3 star 2 plus 5. If you are deriving the string with more than one possibility, then we can prove that the given grammar is ambiguous. Let us see. So here I'm using parse tree method to prove to prove the given grammar is ambiguous. So initially we have some set of production for the given input. So from that, the start symbol E. From the E, I have chosen randomly the production as E star E. And next E, again I chosen that E derives I. Why? Because from the given input, we have first terminal as 3. So the terminal 3 is belongs to the production called I. 2 I derives epsilon or 0 or 1 or 2 something, right? If I have I, then only I can able to derive 3. So that the I have chosen the production E derives I. Again next I derives 3. So now I got 3 star. Next I want to get 2. So again I have choose E derives I. Again I derives 2. But unfortunately here I cannot able to construct furthermore for the parse tree, because here 3 is terminal, I can't able to do further, and here star terminal I can't do further. Again here also 2 I received at the end, so I cannot able to do further iteration or further construction of parse tree. So I go back to I, and I go back to E, and again I replace this E as E plus E by using the given production of the given grammar. So again I replace this E as E plus E production. Again I replaced the E as I. Then finally I replaced choose the production I belongs to 2. And next now I got 3 star 2 plus. Again I need only 5. So what I did is again I chosen the production called E derives I, and the E is replaced as I. Again have chosen I derives 5. So now I got 3 star 2 plus 5. So I have derived the string by using the given grammar. And but what I'm in a position that I want to prove that the given grammar is ambiguous. For that I need to construct one more parse tree for other possibility to bring the same same input string. And in this case, again, I have chosen another production that is called E plus E, because I have chosen E star E, and I proved that the given input string is we can able to get. But now I am chosen another possibility of production that is called E plus E. Again, for the left hand side E, I derives again chosen one more production from the given grammar is E derives E star E. Why? Because in the given input string, actually left hand side we need a star symbol, but initially I have here chosen that plus. From plus I cannot able to start the string because in the the terminal followed by asterisk. But here if I derive directly terminal, it's followed by the plus. So that what I did is I have chosen the next E replaced by E star E. Again, this E as replaced with I by the production of E derives I. Again, I derives 3 this by this production. And next now I got a 3 star. And next I want to, so for that I have chosen the production E derives I. Again, I derives 2. So now I got 3 star 2 plus. And next again I have chosen the production called E derives I, and then I derives 5. Now I got 3 star 2 plus 5. So for the given input grammar, I got two different parse tree. I have constructed two different parse tree to get the given input string. So I got the given input string with two different parse tree constructions. So already we discussed that if a grammar derives input string with more than one leftmost derivation or more than one rightmost derivation or more than one parse tree, we can say that the given grammar is ambiguous. So as of this, we can prove that the given grammar is ambiguous because we have constructed more than one parse tree for the given input string with the given grammar. And next, you just next another example. You consider the following grammar called E derives E plus E, E derives E minus E, and E derives ID. So you want to derive the string ID plus ID minus ID. So in this case, I'm using leftmost derivation to derive the input string. Also, I check whether there is more than one possibility to construct to get the input string with the leftmost derivation or not. So first I derive first leftmost derivation. In this case, I have chosen the production initially called E derives E plus E. And next for the leftmost derivation, I need to replace the terminal as in the leftmost. So for the leftmost E, I have chosen the production called E derives ID, and I have changed this E as ID. So ID plus this is terminal, we can't able to replace. So ID plus as given, sorry, as derived. And next we have another E. For this E, I have chosen the production called E derives E minus E because I can't able to choose here this E as ID. If I have chosen this E as ID, I got ID plus ID all are terms. I can't able to do furthermore. So I have chosen the next production as E minus E for this E, replacing this non-terminal. So ID plus E minus E. And the next step, I have chosen the E derives ID production. So this ID, sorry, this E can be changed as ID. And for the next non-terminal E, again I have chosen E derives ID. Now I got ID plus ID plus, sorry, ID plus ID minus ID. So the whatever the input string is given, that I have derived with the grammar. And the next, I'm trying to get the same input string with any other possibility of the derivation. So initial for the first leftmost derivation, I have chosen E plus E, and now I'm choosing the production E minus E from the given grammar. So now the first production I have chosen that E derives E minus E. Again, for this first non-terminal E, I have chosen E plus E production from the given grammar because so from the given input string, from the left hand side, we need a plus symbol. But what I have chosen from the first initial production, it contains minus. So the first non-terminal I am choosing for the next further derivation as E derives E plus E. Again, next for the first leftmost non-terminal, I replaced ID with the production called E derives ID. And next, again, I have chosen E derives ID for the next non-terminal E. Again, by last non-terminal E also, I have chosen the production called E derives ID. Finally, I got ID plus ID minus ID. So, however, for this leftmost derivation also, we got two different leftmost derivation for getting the same input string. So, already we know that if we have two leftmost derivation for the same grammar to get this one input string, we can conclude that the given grammar is said to be ambiguous as per the rule. Now we got two different leftmost derivation for the same input string. So it's said to be ambiguous. And next, another example is given. The grammar is S derives A capital S B or S S and S derives epsilon. The input string is AABB. So we have to check whether we have more than one possibility for constructing parse tree or constructing leftmost derivation or constructing rightmost derivation. So here I have chosen parse tree method, and S derives SS. As of this production, S derives capital SS non-terminals. Again, S derives epsilon and S derives ASB. Again, this S derives ASB. Again, S derives epsilon. So we got AABB. So one parse tree is over. And next, another possibility. I have chosen that S derives ASB. Again, for this non-terminal, I have chosen again ASB. Again, this non-terminal I have chosen SS epsilon. So now we got the output as A. We are omitting epsilon, B. So A, B, we got. So for since there are two parse tree for single string called AABB, so the given grammar G is an ambiguous. And one more example is also given, that is the given input grammar is A derives AA non-terminals and A derives bracket A and A derives terminal A. So here we have to derive the string called A bracket A. So let us check whether it is possible to construct more than one parse tree for the given input string by the grammar. So A derives AA non-terminals. Again, leftmost A derives AA non-terminal. Again, leftmost A derives terminal A. From this pass, this non-terminal again further derived AA. Again, this A furtherly derived bracket A. Again, within the bracket A derived small a. So now we got bracket A. For this right hand side, A non-terminal A. Again, for this right, the non-terminal A derives as terminal A. So finally, A bracket A. So one parse tree is over. Let us see whether any other possibility for getting the same input string by using the parse tree method with the same grammar. So non-terminal A derives AA, and initial itself I replace it as terminal A. In the last step, right hand side, we have chosen the A. So in this case, I have chosen the left hand side. So again, right hand side non-terminal is derived further AA terminal non-terminals. Again, this left hand side derives AA. Again, this A is there is bracket A, and this A will be a terminal A. So bracket terminal A, and again this non-terminal A has been replaced by the production A derives A. Again, this non-terminal A derives terminal A by using the production called A derives A. So finally, we got A bracket A. So this is again the same input string. So there is a possibility for constructing more than one parse tree for the given input string. So it's said to be ambiguous. Thank you. Thank you all.